Okay, so we've designed our circuit, and we've breadboarded our circuit, and we've written software to load into the 18F4550. So now we're ready to go ahead and actually load the software into the 18F4550. So to do that, we're going to use either the PIC18F4550 or the PIC18F4550. I'll demonstrate both. When you get either of the PIC18F4550 or the PIC18F4550, they'll come with their own USB cable. Here's the one for the PIC18F4550, it's black. And here's the one for the PIC18F4550, it's this nice red color. It really doesn't matter though, it's physically the same cable in either case. So what we're going to do is we're going to plug the USB A end of the cable into our computer. And then we're going to plug the USB B end into the top of the PIC18F4550. Now of course the PIC18F4550 is a USB device, so when we plug our USB cable that goes from the computer into the PIC18F4550, we should get the doink indicating that the operating system has found the PIC18F4550. Also, another thing to notice with the PIC18F4550 is we've got three LEDs here: power, target, and busy. Power is on when the computer is powering the PIC18F4550. That doesn't mean that the power LED, that is, does not mean that the PIC18F4550 is actually connected to the chip yet. And the busy LED is the other one you'll want to keep an eye out on. The busy LED will flash when the PIC18F4550 is doing something such as programming. So let's plug it in. Here are the doink. There we go, the operating system found the PIC18F4550. And now we're going to connect the PIC18F4550 to our breadboard. So here's our breadboarded circuit, same as in the picture shown earlier. Especially take note of this nice 6-pin connector, actually 5 because 1 pin isn't used, programming connector that will allow us with ease to connect the PIC18F4550 to our breadboarded circuit. So now we'll go ahead and connect the PIC18F4550. And now we're ready to go into our PIC18F4550 standalone programming software, which of course is on our desktop. And there we are. I'll zoom in just a tad more. And out just a bit. There we go. That should be good. So, if we double click PIC18F4550, here's the window that comes up. So you'll notice a few things already have been done for us. This device here, PIC18F4550, that wasn't pre-entered. That's the PIC18F4550 realizing that it's connected to the 18F4550 already. That's part of the auto detection user-friendly process of the PIC18F45. Also, we get this nice message here: PIC18F45 found and connected, PIC device found. So it found the chip, everything's working great so far. So now let's go to File, Import Hex, and we're going to navigate to the hex file that resulted from our compilation process earlier. So here we are, 18F4550 blink internal clock.hex. Double click that, and we should get this friendly message here: hex file successfully imported. Now we're ready to write. Now there's some other features in the software, read, verify, erase. You can look at program and data memory, but for now let's not worry about that. Let's just get to writing the program into the chip. So when we choose write, you'll notice if you have LEDs connected to the chip, you might get them blinking. In this case, they will blink because of the pins they're connected to. And there's the blinking, and there's the programming process done. So now we have the nice user-friendly message here: programming successful. The bar is all green, the progress bar is full, so we know the programming process was successful. If it's not, the PIC18F4550 is very good about giving us errors that will help us diagnose what's wrong with the programming process if something goes wrong. Usually if something goes wrong with the programming process, just as a general troubleshooting tip, it probably means that you made the programming data or clock lines too long, or that there's some kind of noise on them. That's usually what it comes down to. But in any case, the programming process went great for us here. So now on the right side of this software here, we have VDD PIC18F45. So once we check this box, the PIC18F45 through its power and ground pins, pin 2 and 3, will apply power and ground to our board. And it's going to apply however much voltage we choose here, so in this case 5 volts. So now let's zoom out just a tad, and now I'll check the box and the LED should blink. And there we have it. So we've successfully written our software and loaded it into the 18F4550 and tested it with the PIC18F45. So now let's demonstrate the PIC18F45.